Welcome to MathStuber everyone. So in the last video of differential equations, we have covered the two um, forms of solving the differential equations, and now we will discuss the third form, which is called linear differential equations. So I'll just write down. We are going to discuss linear differential equations. And this linear differential equation is of the form dy by dx plus py equal to q, right? So it is of this form. Now, in this form, first of all, what we have to check is there should be dy by dx, and the coefficient of dy by dx should be equal to 1. If there is any other coefficient other than 1, then you have to divide the whole equation by that particular term. Then after that, the coefficient of y will be called p here, and we have to write p in place of that only, and q is the remaining part. So we have to change the whole equation into this form. This is the standard form for a linear differential equation, and we have to find the values of p and q first, right? After that, if we have got the values of p and q, then we will have to find out the integrating factor denoted by if. So it is integrating factor, which is e raised to power p dx, right? Now this p and q will be in the form of variable x. And also one more thing, uh, if you are doing the integration of p dx, you will not write c here. The constant of integration, you will not write it in integrating factor. It will be only the it will be only the integration of that particular function, right? Now the next is, if we have got the value for integrating factor, then the differential equation will be given by it will be given by so y into integrating factor is equal to integration of q into integrating factor dx plus c. This is the standard form of differential equation that we have to find out. Then we have to solve the integral here, and then that will be your answer. Other than this, if the standard form of linear differential equation is in the form dx upon dy, right? So here it is dy by dx, but somehow if it is in the form dx upon dy, then in that case, the form will be dx upon dy plus p into x. Now the x and y will replace each other, right? Now p is the coefficient of x here, and q is the remaining term, and p and q will be in the form of y. Now the integrating factor will also be e raised to power p dy, right? And the differential equation will also be is given by x into integrating factor is equal to q into integrating factor into dy plus c. This will be the standard form of the differential equation if the linear differential equation is in the form of dx upon dy, right? So everything is same here, just the difference of x and y. So now let us understand the questions. Let us come to the exercise number 9.5 here. So, exercise 9.5, question number 1. So, here we have dy by dx plus 2y equal to sine x. So, clearly, we can compare this with the standard form. It is already in standard form, so we don't have to do anything. Comparing with dy by dx plus py equal to q. So p here is 2 and q here is sine x. Now the integrating factor, we know that it is e raised to power p dx. So it is e raised to power 2 dx. That is e raised to power 2x. And I told you that we don't have to write plus c here. The constant of integration will not be written. Right. Now after this, the differential equation is given by y into integrating factor, that is e raised to power 2x, is equal to q into integrating factor, that is sin x into e raised to power 2x dx plus c. So now in this one we have to apply the integration by parts, right? So according to I late, this should be first and this should be second. So y into e raised to power 2x is equal to first as it is integration of second minus integration of the differentiation of the first function. Uh, so it is cos x into integration of the second function e raised to power 2x dx into dx plus c. So it is y into e raised to power 2x is equal to 2. Actually, we have to do this function, means the integration of this function separately, because this is a kind of form where we will get I again, right? So let us do it separately and then we will substitute the values here. So let us take this as the first equation and let I equal to integration of sin x into e raised to power 2x dx. Now, after this is the first function, this is the second function. So I will be equal to sin x integration of e raised to power 2x dx minus integration of differentiation of the first function, that is cos x, into integration of e raised to power 2x dx plus c, right? Which is equal to sin x into e raised to power 2x upon 2 minus cos x into e raised to power 2x upon 2 plus c, and the integration of this one. And after that, we have to apply the integration by parts again. We will take this 1 by 2 to the means outside of the integral. So let's write it again here. I equal to e raised to power 2x into sin x upon 2 minus 1 by 2 cos x into e raised to power 2x dx plus c. Again, this is first and this is second. So e raised to power 2x sine x divided by 2 minus half first as it is second का integral होगा, so it will be e raised to power 2x upon 2 minus integration of the differentiation of the first function. So differentiation of cos x is minus sin x, so it will become plus sin x into e raised to power 2x upon 2 plus c, right? And here it is dx. Now, if we take this 1 by 2 outside the integral, this will be sin x into e raised to power 2x, which was I in the starting. As you can see here, sin x into e raised to power 2x dx is I. So we can replace the value of this. It will be e raised to power 2x into sin x divided by 2 minus 1 by 4 cos x into e raised to power 2x minus 1 by 4 into I हो जाएगा plus c. So if we take this 1 by 4i to this side, you will get I plus I by 4, which is 5i by 4 is equal to e raised to power 2x sin x divided by 2 minus cos e raised to power 2x divided by 4 plus c. And if we multiply the whole equation with the 4 by 5, so you'll get the value of I from here. So I will be equal to I will be equal to 4 by 5 into e raised to power 2x sin x divided by 2 minus e raised to power 2x cos x divided by 4 plus c. So 4 by 5, it will become, if we open the bracket here, I think it will become, if we take 4, sorry, e raised to power 2x upon 4 common, you will get 2 sin x minus cos x. So 4 will get cancelled and you will get e raised to power 2x upon 5, 2 sin x minus cos x plus c. So this is the value of I here. Now substitute this value of I. Now from equation number 1. So equation number 1 was y e raised to power 2x equal to I plus c. So we have to just substitute the value of I here. So it is y e raised to power 2x is equal to e raised to power 2x upon 5, 2 sine x minus cos x plus c. And this will be the answer, right? So this is how we have to do this question. It's just we have to first of all, we have to compare it with the standard form of linear differential equation, find the values of P and Q, and then find the integrating factor, and then put it in the um, differential equation and then solve it, right? Now let us try some more questions. So here we have the third question. Let us do the third question. Dy by dx is equal to, plus y upon x is equal to x square. Now, if we compare, this is already in standard form. So, comparing with dy by dx plus py equal to q. So, it is p equal to 1 upon x and q is equal to x square. And the integrating factor here is e raised to power 1 upon x dx. which is e raised to power log x. And e raised to power log is 1, so it will be x only, right? Now, if we have the integrating factor here, we will find therefore the differential equation is given by y into integrating factor is equal to q into integrating factor integration dx plus c. So it is y into x is equal to integration of x square into x dx plus c. It is x cube. So the integration of x cube is x raised to power 4 upon 4. And if we multiply this whole by 4, so it is 4xy equal to x raised to power 4 plus 4c. You can take it as c1 here so that we can write it as capital C, right? So 4xy equal to x raised to power 4 plus c. This will be the answer. Now, let us try some more questions. Let us try the fifth question. So the fifth question is cos square x dy by dx plus y equal to tan x. So I told you that in the standard form of linear differential equation, there should be the coefficient of the of dy by dx should be 1. And if there is any other coefficient, then we have to divide the whole equation by that. So we have to first divide the whole equation by cos square x here. So if we divide the whole equation by cos square x, you will get dy by dx plus y upon cos square x is equal to tan x upon cos square x. And 1 upon cos x is sec x. So it will become sec square x into y is equal to tan x into sec square x. Now we can compare it with the standard form, comparing with dy by dx plus py equal to q. So comparing it, we will get the coefficient of y is p. So it is sec square x, and the value of q is the rest tan x into sec square x. This will be the value of q. Now we will find out the integrating factor here. Integrating factor is given by e raised to power e dx. So integrating factor is e raised to power sec square x dx. This will and the integration of sec square x is tan x. So e raised to power tan x is the integrating factor here. Now we have to find out the equation here. So the differential equation is given by y into integrating factor is equal to q into integrating factor dx plus c. So y into integrating factor is e raised to power tan x is equal to q is tan x into sec square x into e raised to power tan x dx plus c. And we know that the differentiation of tan x is sec square x. So we can substitute it here. Put tan x equal to t such that sec square x dx is equal to dt. So it will become y into e raised to power tan x is equal to integration of t into e raised to power t dt plus c. And now we can apply the integration by parts here. So this will be y into e raised to power tan x, which is equal to first as it is integration of second minus derivative of the first function, which is 1 into integration of second function dt plus c. Now again we have to do the integration of the of et, which is e raised to power t only plus c. y e raised to power tan x. Now, if we substitute the value of t here, it will become y e raised to power tan x is equal to tan x e raised to power tan x minus e raised to power tan x plus c. This will be the answer, right? This is how we have to solve the questions. After this, let's try the seventh question also. So the seventh question here is x log x dy by dx plus y equal to 2 upon x into log x. This is the question. First of all, we have to divide the whole equation by x log x. dy by dx is dy by dx plus y upon x log x is equal to 2 upon x into log x upon x log x. Log x will get cancelled. Dy by dx is equal to plus y upon x log x is equal to 2 upon x square. Now comparing with dy by dx plus py equal to q, right? Then if we compare it, the value of p is 1 upon x into log x and the value of q is 2 upon x square. Now the integrating factor here, it's a bit complicated because we have to substitute the value as well. So there's x 1 upon x log x dx. We know that the derivative of log x is 1 upon x. So we can substitute here log x equal to t, and the answer is 1 upon x dx equal to dt. So it will become e raised to power 1 upon t dt, right? Then this will be e raised to power log t, which is t only, which is log x. So integrating factor here is log x. Now, putting all the values in the differential equation and then solving it. Differential equation is given by y into integrating factor is equal to q into integrating factor dx plus c, which is y into log x is equal to 2 upon x square into log x dx plus c. Now, 2, we will take 2 outside, and this is log x into 1 upon x square dx. So according to Eilert, this should be first and this should be second, right? So here, first as it is, integration of the second. So the integration of 1 x raised to power minus 2 will be, it will be minus 1 upon x minus differentiation of the first function into integration of the second function dx plus y into log x. Now, solving it, we will get y log x is equal to 2 into minus 2 log x upon x and plus 2 1 upon x square dx plus c. So now again, if we integrate it, y log x is equal to minus 2 log x upon x plus 2 into minus 1 upon x. Integration of 1 upon x square is minus 1 upon x plus c. And multiplying the whole equation by x here. So xy log x is equal to minus 2 log x minus 2 plus cx. This will be the answer. So this is how we can solve the questions very easily. Now let us try a question based on dx upon dy here. So most of the questions are having dy by dx, but I think let's try the 11th question once. In the 11th question, we are given with y into dx minus x minus y square dy is equal to 0. So here we can either make it as dy by dx or dx upon dy, but it depends on what kind of equation we will get after that. So let us try with the normal method. If we take it as dy by dx, so y minus x minus y square into dy by dx is equal to 0. We have divided the whole equation with dx. Now, so if we take this to the other side, you will get this. And for this, we have to take it to this side. Now we have separated this dy by dx, and the coefficient of y should be there, which should be here. But if we take this y upon x minus y square to the left hand side, the coefficient of y is x 1 upon x minus y square, which is not in the form of x only. It is in the form of both x and y, which is not applicable here because both p and q should be in the form of x. So we now know that by doing dy by dx, we cannot get this solution. So we have to try with dx upon dy now. So divide the whole equation by dy. You will get y into dx upon dy minus x plus y square equal to 0. Then dividing the whole equation with y also, because we want uh, the coefficient of dx upon dy is 1. So this is dx upon dy minus x upon y plus y equal to 0. Now we want the coefficient of x here. So we will keep it here like this and is equal to minus y. Now if we comparing with dx upon dy plus px is equal to q. So p will be minus 1 upon y and q will be equal to minus y, right? Integrating factor is e raised to power p dy. So it is e raised to power minus log y, which is e raised to power log y raised to power minus 1. And this is 1 upon y because e or log to cancel ho jayenge. We'll get y raised to power minus 1, which is 1 upon y only. So now we have the integrating factor. And now differential equation is given by x into integrating factor is equal to q into integrating factor into dy plus c. So x into 1 upon y is equal to minus y into 1 upon y dy plus c. Y will get cancelled, you will get minus y plus c. x upon y, and this will be x y is equal to y square plus cy, and this will be the answer. So this is how we can do the questions. It's a simple method. You just have to remember where we have to put dx upon dy and where we have to put dy by dx. Similarly, the 12th question here, if you do it with the help of dy by dx, you will not be able to do it. Same here, like we have done in this question. So you have to first convert it into dx upon dy. Let me tell you the starting of this question, and then rest you can do by yourself. So in the question number 12, we have x plus 3y square dy by dx is equal to x. No, y. So if we take dy by dx, we need the coefficient of y, and the coefficient of dy by dx should be 1. So we will take this x plus 3y square in the denominator of y, which is again not a standard form for linear differential equation. So what we need to do here is we will take this dy by dx to the other side. We will cross multiply it, and you will get y into dx upon dy, right? Now divide the whole equation with y. You will get x upon y plus 3y equal to dx upon dy. So dx upon dy के साथ हमें y का x का कोफिशिएंट चाहिए होता है, तो it will become minus x upon y is equal to 3y, right? So now if we compare it with comparing with dy by dx, sorry, dx upon dy plus px is equal to q. So p will be minus 1 upon y and q is 3y. And the rest you know already. Integrating factor we have to find. Now it is the same question as 11th question. So you can do it by yourself. Now let us try the particular solution questions, which are 13, 14, and 15 questions. So here in the particular solutions, we have to find the value of c by using the value of x and y, which is already given in the question at the last, right? So let's try the 13th question here, which is dy by dx plus 2y tan x is equal to sin x. And here y equal to 0 when x is equal to pi by 3. This is given. So if we compare, this is already in standard form. Comparing with dy by dx plus py equal to q. P is 2 tan x and q is sin x. So integrating factor is given by e raised to power integration of p dx, which is e raised to power 2 tan x dx. So the integration of tan x is log of sec x, right? So if we take this 2 to the power of sec, you'll get sec square x, and e raised to power log is 1, we know that. So the integrating factor now comes out to be sec square x. So now we will substitute all the values. Therefore, differential equation is given by y into integrating factor is equal to q into integrating factor dx plus c. So y into sec square x is equal to sin x into sec square x dx plus c. And we know that this can be written as sin x upon cos square x dx plus c. So the integration of, no, the differentiation of cos is minus sign, right? So we just have to adjust minus here. So we'll take minus from outside and we'll put cos x equal to t. So it is minus sin x dx equal to dt. So here you will get y sec square x is equal to minus of dt upon t square plus c, which is minus 1 upon t plus c, 1 upon t plus c, and the value of t is 1 upon cos x plus c, which is sec x plus c. So y sec square x equal to sec x plus c. Now we can substitute the values, which is given as y equal to 0 when x equal to now y equal to 0 when x is equal to pi by 3. So it is 0 into sec square pi by 3 sec pi by 3 plus c. So sec pi by 3, we know that its value is 2. So c will be minus 2 from here, and therefore the equation is given by y sec square x is equal to sec x minus 2, and this will be the equation, right? This is how we can easily do the questions. Uh, the rest of the questions are the same kind of questions. In the 18th and 19th questions, we have to just find out the integrating factor. So that's an easy one. And the rest of the parts you can try. 16th and 17th, I don't think we have to do it because these kind of questions don't come in examinations. Then we have the miscellaneous questions here, and we will try a few miscellaneous questions, and the rest you can do by yourself, right? So most of the questions are of the same kind. Like the first question here is we have to find out the order in degree, and we have discussed in the first video that order in degree are order is the highest order derivative that is being used in the question. And the degree is always the power of that particular highest order derivative. But there is some problem with the degree that we have to check, that any derivative, if it is in the function trigonometric function or inverse trigonometric function or logarithm exponential or any kind of these functions, so the degree will become not defined in that case if it is not removable, right? So you can try these questions. Then the second question is based on the second exercise where we have to check the solutions, right? So I will do one question second of miscellaneous. I'll do first part of it. Xy is equal to a e raised to power x plus b e raised to power minus x plus x square, and we have to check it for x d square y by dx square plus 2 dy by dx minus xy plus x square minus 2 equal to 0. So we'll first find out dy by dx and d square y by dx square. So first order derivative and second order derivative. So we'll differentiate it. First function as it is, differentiation of second plus y as it is, x ka derivative is 1. A into e raised to power x minus b into e raised to power minus x plus 2x. Then again, um, okay. So now we have dy by dx, but here we have to find out dy by dx properly. So for that, we have to take this y to the other side. A e raised to power x minus b raised to power minus x plus 2x minus y, and dividing it whole with x. So you'll get the value of dy by dx, which is a e raised to power x minus b e raised to power minus x plus 2x minus y whole divided by x. So this is the first, right, that we have to use. Now from this equation only we will find out the value of d square y by dx square. So in this one, first function as it is, derivative of second plus dy by dx as it is, x ka derivative is 1. Thus this is also y ka derivative is dy by dx is equal to a e raised to power x plus b e raised to power minus x plus 2, right? Okay. After this, we have dy by dx plus dy by dx. So this is x d square y by dx square plus 2 dy by dx is equal to a e raised to power x plus b e raised to power minus x plus 2, right? After this, let us take this as the second equation. Well, we got the value for the LHS here. The LHS is given as x d square y by dx square plus 2 dy by dx minus xy plus x square minus 2. So put the values here. The whole value of this is from the second equation here. A e raised to power x plus b e raised to power minus x plus 2. Right. The value of xy is given in the starting here. The question itself was the value of xy, which is a e raised to power x plus b e raised to power minus x. So it is minus of a e raised to power x plus b e raised to power minus x and plus x square plus x square minus 2. Now opening the bracket here, you can first of all cancel these two. A e raised to power x plus b e raised to power minus x minus a e raised to power x minus b e raised to power minus x square plus x square. X square are getting cancelled and all the other terms are also getting cancelled, and the answer is 0, which is equal to RHS. So this is how we have verified the uh, given function, that it is the solution of the given corresponding differential equation, right? This is how we have to do it. Now let us try some differential equations here. So here in the third question, we have to prove that x square minus y square. Okay, this is a general solution of the. Okay, that is the same question. We have to find out dy by dx first, and then we have to substitute the values, right? So here x square minus y square is equal to c into x square plus y square whole square. And okay, we have to first find out the value of dy by dx. So 2x minus 2y dy by dx is equal to c into 2 into x square plus y square into 2x plus 2y dy by dx according to the chain rule. Then after that, we take 2 common from here. We'll get x minus y dy by dx is equal to If we take 2 common from here also, and one more 2 is here, so it is 4c x square plus y square x plus y dy by dx. So 2 will get cancelled. X minus y dy by dx is equal to 2c x square plus y square x plus. Okay, there is one problem with this question that we will not be able to separate dy by dx from here as it is a little complicated. So we have to change the first step here, and that is, I'll tell you. So here it is x square minus y square is equal to c into x square plus y square whole square. So what we are going to do is x square minus y square upon x square plus y square whole square is equal to c. Now we will differentiate it, right? And if we differentiate it, we will have to apply the quotient rule here, and the derivative of c will be 0. So here it will be x square plus y square whole square. X square plus y square whole square as it is. The derivative of this is 2x minus 2y dy by dx minus x square minus y square as it is. And this will be 2 into x square plus y square into 2x plus 2y dy by dx is equal to 0. Then if we cross multiply this, the denominator will go to the right hand side and then it will become 0 only. And after this, we have, okay, there is one more thing. We can take x square plus y square common, and also 2 can be taken as common. So 2x square plus y square is common. You will get x square plus y square x minus y dy by dx minus x square minus y square 2x plus 2y dy by dx is equal to 0. Then this 2x square plus y square, if we take it to the right hand side, it will also become 0, right? And then we have to multiply this whole and separate dy by dx out of it. So it is x square plus y square x minus y dy by dx is equal to 2 into, we have taken it to the other side, 2 into x square minus y square x plus y dy by dx. So it will become x cube plus, sorry, minus x square y dy by dx plus xy square minus y cube dy by dx is equal to 2 into x cube plus 2x square y dy by dx 2xy square and minus 2y cube dy by dx. So now take all the dy by dx terms to one side so that we can take dy by dx common, and the non dy by dx term to one side. It is 2y cube minus x square y minus y cube minus 2x square y dy by dx is equal to 2x cube minus 2xy square minus x cube minus xy square. Okay, so it is y cube minus 3x square y into dy by dx is equal to x cube minus 3xy square, and we can take x common from the numerator and y common from the denominator. Dy by dx is equal to x square minus 3y square upon y square minus 3x square. This will be the value of dy by dx. So now what we have to do is, okay, we have to prove that the general solution is this. So, okay, that's fine. So we don't have to put anything. Before doing this particular step, we just have to, in the last step, what we have to do is we have to take dx to the other side only, and we will get our answer. So that's it. So it is very easy. Y cube minus 3x square y cube minus 3x square y into dy is equal to x cube minus 3y square x into dx. And that is the answer. So we have proved that the general solution is this one, right? That's a direct question, and this will be the answer. This is how we have to do these type of questions, and you can try the rest of the parts. There are a few questions here, so you can try these questions, and we will continue with this in the next video. Thanks.